Hello and welcome to Data Science, Introducing the Data Science Platform with Erwin Lares. It's 11 o'clock on day 2. Erwin's going to explain this wonderful data science platform that we have available to us. I got a quick preview of it, and it's great. I'm looking forward to seeing it again. And take it away, Erwin.
All right. Well, of course. Good morning. My name is Erwin Lares, and I'm here to tell you about this product that I lead called the Data Science Platform, that I'm very excited about it. Yeah. I just want to share with you what it is and give you a preview of it. My goal for today is that you walk away knowing a little bit about what it is and with the conviction that your researchers should be getting an account with us, because I believe it's a great product. A little bit about me. I recently graduated from UW-Madison with a PhD in linguistics. My dissertation, I use RStudio and R to do all the computation, and so that's how I get involved with this. And now I'm on the side of providing that service to the rest of campus. So I'm going to try to do something a little bit risky today. I'm going to be live coding. One person requested an account. I share with that person the URL, and you should follow along. I said code along, but it's more like play along. There's not a whole lot of things to code. And like I mentioned, I'm going to play with 3 ideas, basically. I'm going to have the code here, which I will be rendering into this document that you see on the right. So any changes that I see here, we'll re-render and we'll see what happens there. And then I have a few other scripts that we're going to visit as we move along. And the other things that I'm playing with is I have these 2 contexts in which I want to place my talk today. The first context is, you probably have seen this, is the research life cycle. And it involves, when someone comes with an idea to research, they plan, then they have to gather data, and they have to analyze and visualize that data. And they have to publish their research findings, and eventually they have to close out and be done with it. And what is neat about the data science platform is that it occupies several of these steps of the research life cycle. And I'm going to highlight when we're doing each one. The second thing that I wanted to provide context with, that's awesome. It's when I was initially planning this talk, I thought I was just going to come and tell you, this is what the data science platform is, and these are, the key specs of it, and this is what you get, and be done with it. And I thought that was going to be a really boring talk. So instead, I'm going to walk you through a fictional research team that has a project, and we're going to see some of the needs that the team has and how the data science platform can address those needs. So let me start here. Let me render this again. Amanda said, and I want to emphasize that if you have a question at any time, feel free to stop me. Okay. All right, so again, welcome to the Data Science, Introduction to the Data Science Platform. I'm part of a team called the Research Cyber Infrastructure, and we are a unit within Do It, and we were created very recently to address some of the needs researchers face today, such as working with different kinds of data types, collaborate with other institutions, leverage on-campus and cloud computing resources, and move data to and from remote locations. We aim to provide resources and support that are reliable, available, effective, secure, and we believe that helping researchers use this new modes of computation and visualization will enable them to move their research further. Research cyber infrastructure basically comprises 4 services, and I'm just gonna briefly touch on all 4 of them. The first one is ResearchDrive and Globus. ResearchDrive is a storage solution that revolves around a local initiative called ResearchDrive. Usually ResearchDrive is coupled with Globus, which is it's a web-based tool that is designed to transfer and share data. So a few things that are important about ResearchDrive, give you access to, well, now it will be 25 terabytes of storage that are free of charge for researchers on campus. ResearchDrive and Globus meet compliance requirements for both restricted and non-restricted data. Both services support data sharing and collaboration. ResearchDrive meets data management and compliance requirements. Globus allows you to move data between research cores, computer centers, storage systems, the public cloud, external collaborators, and you can check those at our website, researchci.it.wis.edu. The second service that we run is the electronic lab notebook. So we administer lab archives for research, which is a cloud-based lab notebook that allows for a centralized location to record and document processes and procedures, manage observations, results, collaboration with other for all types of data types. The service is supported in a partnership between campus libraries, DoIT, and CAL's IT staff. A few features that you can find if your lab uses research lab archives is you have searchable entries, you have unlimited storage, you can access your lab notebook from anywhere, you can have shared notebook collaboration, built-in versioning. It is approved for restricted data, and it gives you an activity audit trail immediately. There is a Teams channel where you can find things that are happening with lab archives, and you can use that link there. I will place it in chat too, so you have it if you're interested in it. The third big group of tools that we have, we call them cloud tools, and basically we will help you gain access to the 3 main cloud providers, AWS, Azure, and GCP. We help you get access to virtual private clouds, compute units, storage. We help you run applications in the cloud. We can help you with automation tools, and we can help you with training on specific tools. And finally, the data science platform, which is the service that I lead, and the features that you can expect here is a familiar programming environment that you can see right now on the left here. You can choose between RStudio, which is what you're seeing there, Jupyter Labs, or VS Code. You can code in the language that you want, and those are right now just R and Python. Access your data and analysis from anywhere. You can access more computer power that your personal device usually can give you. You can share your research artifact easily, and you can schedule your script easily. So as I mentioned before, the goal of my talk is to give you a taste of what the data science platform is. And I gave you a little bit of what my thought process was to give you this, not just a list of features, but rather I'm going to show you how a team of Penguin researchers are using our services to conduct their research. So I'm going to pause for a second in case anyone has a question before I move forward. All right. So the framework for this is that I'm going to pretend and to help you with visualize this. This is an actual piece of research that occurred between 2007 and 2009 by Dr. Kristen Gorman, and she and her team were at the Palmer Station down in Antarctica, and they collected these measurements of penguins that live in 3 adjacent islands. And so my fictional team is the Penguin Research Project, and they secure a grant to continue tagging and measuring penguins for science. So the first step that the Penguin Research Project team did was to get in touch with Dr. Gorman to secure a copy of the original data set. And she did so by creating a Globus endpoint. And so what I'm trying to do here then is to have this fictional team and at the same time correlate their needs to the things that research cyber infrastructure can do for you. So Globus is one of those services. And so when we get in touch with Dr. Gorman, she created this Globus endpoint to access her data. Once a researcher has set up an endpoint, the data mapped to that endpoint can be accessed from anywhere in the world. The authentication is managed by Globus researchers, and researchers have fine-grained control of how their data can be accessed. So to give you an idea, this is what Globus looks like. So this is my account on ResearchDrive, and I can map parts of my ResearchDrive to Globus, so Globus can access it. So in this particular case, I created a folder that I call public data. And in there, I have some, as you can see, the theme is penguins, some penguin related files. And I also, just to, as a point of, to give you an idea, you can have levels of very fine granular control over how you share your things. So I could, like if I decide to choose this, I can grab a link and I will only be choosing that. But if I have a folder called Stevens Point, I can choose to create a link and everything in that folder will be made accessible through Globus. So that's the idea. And so I get access to this data that Dr. Gorman set up simply by running this line of code in R. And so when I do that, now if I go see my environment, I have my original penguins, and it was composed of 333 observations. So before I move forward, let me tell you a little bit more about the data science platform. So it is composed by 3 services running on VMs that are hosted on CCI servers on campus. Of those 3 services, I'm going to talk about the 2 user-facing ones, Workbench and Connect. Now, Workbench and this is directly from their website, is the place for teams to collaborate, build open source data science project at scale. It supports both R and Python, and it gives data scientists access to all the development environment they love, including RStudio, JupyterLab, and VS Code. It provides enterprise-friendly features such as centralized management, security, and commercial support. And what Workbench looks like, the joys.
Yeah. Cursive live demos. While that's we have a couple of questions about who is eligible to use this, whether it's just research staff or research faculty, or if administrative staff can use it, if they aren't research staff.
That's a great question. Thank you for asking that. Any researcher, any PI is eligible to request an account. We are in a pilot phase. So one of the main motivation for me to be doing this is to gather interest for people to try the platform, so that in a year from now we can make a good case that this is a service that should be made permanent. So my goal, as I mentioned at the beginning, is for you to go back to your department and talk to your researchers and tell them you need to try this. And hopefully I'll convince you by showing you how cool this is.
And if we're administrative staff that want to use this for analysis, who do we complain to get them to push?
Yes, we have already some people doing that, and more people are welcome. We're still crafting policies. So not to get into the weeds of it, but the contract is quite restrictive in some aspects. So we're trying to do our rotation system, but it has been difficult to implement. So I'm still working on it. But if you are, besides a PI, you are faculty, staff, we have grad students, postdocs too. So anyone from campus can request an account, in short. And I will let you know how to do that at the end. So let me go back to, so this is what Workbench I was mentioning. This is what Workbench looks like when you just logged in. You log in with your NetID's credentials, and when you're here and you start a new session, then you simply choose, I want a new session in Jupyter Notebook, a new Jupyter Lab, or a new RStudio, or a new VS Code. You click the one you like, and you start your session. And it is as simple as that. So let me reconnect here. And let me re-render this. And where were we? We were here. So I was mentioning that it is composed. This is where I was, right? Remember?
I believe so. On the three different, the two public facing.
Right. So Workbench that I showed you just now, and the other side of the platform is Connect. Now Connect looks like this. It looks very simple. What is interesting here is that Connect is a publishing platform, and you can publish quite a few things to here. And I'll give you examples in particular, but just to give you an idea, I have here a API that I publish. I have some scripts that I publish. It's an R Markdown document. I'm publishing some data sets. And I have a plot that I published. But this is my test environment. But if you go to our production Connect, then we have lots of people publishing Shiny apps and all sorts of other things. Just to give you an idea of a Shiny app, this is a Shiny app that I created for the Lab Archive service that we host. And so it just tells us activity is a dashboard for activity for different labs within a unit. So if I choose letters and science, and this is it's showing me labs in the 90 to 100% a range of activities, which are the labs more, this year. And it just gives you a rundown through the years. And you can do a couple of filtering and whatnot. But this is what the production Connect looks like. But I'm going to stick with the test connect. Speaking of it, we're going to be moving away from the production environment into a new, we secure some new VMs, and they are live as we speak, and I'm working on migrating them within the next few days. And those environments are similar to what you're seeing here. One of the pilot has been running for a few years. And one of the lessons we have learned is that the VMs that we provision on the Amazon cloud, we're really not filling in this gap that we were advertising to be more than a laptop, but not quite as powerful in, not as much computing muscle as, say, CHTC. So it was intended to fill that middle ground. And in reality, it was not. But the new ones are. They are more powerful and more memory, more storage. So I'm looking forward to see researchers using them. So this is what the platform is. It's Workbench and Connect. And there's a third product here called Package Manager that all it does is facilitates libraries and packages. It downloads the binaries and makes them available faster. So we're gonna go back to our Penguin research project. And so if you have access to ResearchDrive, and the eligibility is if you're a researcher on campus, you have access to it. You just need to request an account. But if you do, then you can access all the storage easily within your Workbench session. So for instance, let's save, and I'm here, right? Let's save the Penguin data set that we got from Dr. Gorman. Let's save that to ResearchDrive. So we don't have to be hitting that global endpoint every time we need the data. And what that means from this environment is that you grab your original data, those 333 observations, and you simply do a write _CSV to ResearchDrive, and it's made available behind the scenes. You don't have to do anything. And I'm gonna run this, and I'm gonna cross my fingers. Sometimes my Kerberos tickets expire, and then this doesn't work. But in this case, boom, it does. So right now, I just wrote to those 25 terabytes of data that I have available to me. And as you can see, you don't have to do anything other than know your path where you want to write it. It's pretty nifty. So let's do a little bit of touring the data science platform with the Penguin research project. So they want to do a quick exploration of this data we got. And for these purposes, we're going to use the GT package. So we're going to grab the data. We're going to grab the first 10 rows, and we're going to feed them to the GT package. And we're going to add a couple of things like a title, a subtitle. And what that looks like is this. So you have your original Penguin data set. That's the title, the subtitle, and we see here the first 10 rows of data. We see that the categorical variables are species. There are 3 of them: Adelie, Chin, Stripe, and Gentoo. Islands, where they were, captured and measured, and the sex of the specimen. There was also a numerical variable. The rest of the variables that they capture is the length of the bill, the length of the flipper, how heavy they were in grams, and length and depth, how long and how wide the bill is. And so normally in the process of doing data science, one of the things we do is we visualize, and it's as easy as this. So the Penguin research team rely on some popular packages, ggplot in this case, to get a sense of how the original data is distributed. And here we see that for the females, we have Adelie are the smallest one. We have here on the vertical axis the body mass, how heavy they were. Adelie are the little ones, chin strap second, and very much bigger penguins are the Gante ones. And here on the right side, we have for the males, Adelie are slightly larger than chin strap, but Gantus, male Gantus are still the biggest ones. And that's cool. And we have a nice plot with just, these lines of code. Nifty. So what is the problem that PRP is trying to solve? Well, the thing is that in this fictional world, due to climate change, the penguins have started to migrate to another island that is closer to the South Pole because they like the cold. They don't like to be melting like we are here in Wisconsin. So the researchers are tasked to identify those penguins that are trying to share the same space. And they're moving to this island called Janus Island. And they want to prevent the great penguin calamity from happening. And they have to measure and tag and know where those penguins are, all those kind of things. And so to do that, they have a couple of challenges in front of them. One of them is that the team is multilingual, multi-platform, and multi-software. So how do they deal with that? Well, some of the researchers use R, but some other researchers rely on Python. And there are people who use neither. And so how do you work around that? That is a common problem that most research teams might have. And the data science platform might have some solutions for that. So, and this is where Connect becomes very useful and to this problem. So Connect is a publishing platform for the work your team's creating either R or Python. And actually, you can use quite a few other languages. Zoom in the pipeline is support for Julia, but at this moment right now, R and Python are working just fine. And it allows you to share Shiny applications, like the one I showed you earlier that I did to show which labs are the most active. That's a Shiny app. R Markdown reports, if you have a report that you need to update frequently, that's a great way to do that. Plumber APIs, and I will show you one down the road. Dashboards, Jupyter notebooks, interactive Python content. Those are quite a few of those things that you can do. What I'm going to show you is how to leverage Connect to use this plot that we created. So to do that, I'm going to use something called the pins package. So the pins package is a nifty package that allows you to create boards. Once you create a board, you can pin objects to it. And I said objects because you can pin anything that you can create on R, be it a plot, a model, a table, data, whatever you can create on that, you can pin to a board. And then you can give people access to that board. And so if you are on Python and you are interested in those plots, you don't have to recreate the plot using Python script. You just grab the latest plot from the board, and that's great. So the first step is to create a board. After you have the board, you pin the object to it. And this takes 3 arguments, the board, the object, and the board, the object pin, and a name. So let me go back here. This created this plot here, and I assigned it back to something called penguin plot, right? So when I want to use Connect to share research artifacts, I can do this very simply. So let me show you how. So this piece of code here creates a board. It's called CCI Connect. And I'm gonna run that line. And now I have CCI Connect right there. Well, actually it doesn't create a board. I misspoke. This grabs, I have some some values hidden from in our environment. I keep some important information that I don't want to share, so I access it through this, and then I going to create this object board where I tell them who the server is, and the server is this server here. And then I'm going to create a board and write my penguin plot to that board that I created there. And I'm gonna tell it that it's version, and I'm gonna give it a description. So I'm gonna do that right now. Oh, sorry. Create that, I create that, and now I save it. Okay, good. So now on Connect, there is a board here. And today at, is that the right time? Well, this just happened at 34, but I guess it's in some other time zone. I updated this board, this plot. So once we have pinned that board, other people can easily access the object. So if anyone wants to read the board, I just make sure that the board is the right one, and then I can call in, I'm gonna call pin read on that plot. I'm gonna assign it to this plot object, and then I'm going to plot it. And there it is. So what's neat about this is that you can, by default, those things are versioned for you. So you will retrieve the latest version, but you can list all the versions and maybe pick one that is more interesting to you. So if I list the versions that I have available, so you can see you have all of those, the date, the time, the size, and whatnot. So why is this useful? Let's say that here, let me just open this. Here, the funding group that is funding my research is not interested in body mass. It's interested in flipper length. If I run this, that is the new plot, and it has flipper in the vertical axis, and we can see that unlike the weight, the adult penguins have shorter flipper length than chin strap for both males and females. And if I save that to my board, I can now retrieve that board in particular. And what is interesting now is that now that I know that this is version 133, 133, I know that this one is for body weight and this one is for flipper length. I can just tell, hey, give me just the one that I'm interested in. And so you have all those plots saved, version, and you can access them individually as you want. So in this case, I'm going to access the flipper length, not the body flipper length. Everything is good. I got somebody in my research team is like, oh, I need the body math. Just, oh, sorry, one prior. And there's the one with body mass. And it's as simple as that. So I showed you quite a few things right now. I'm going to pause and see if you have any questions. And Amanda, please feel free to help me navigate the questions.
Yeah, there's a couple of very detailed questions here, sort of technical details. After the eligibility one, there's will this be tied to the resources and training at the Data Science Institute or the Data Science Hub?
Okay, will this be tied to the resources, help training, and Data Science Institute or Hub? Well, we're working on collaborating with them. Part of my job includes training and consulting. So if you decide to try if one of your researchers decides to try our services and they need help, I'll be involved in that. And I think this is one of the greatest parts about the job I have. It's like every other day, it's like, oh, we want to do this. How do we do this? And it's just a rabbit hole there. So would this be available? We're working on it to make it so. Research, computing, and data are distributed across campus.
Yeah. Thanks for putting that link in there, Mary.
That was a comment. Okay, is GPU capacity included? Great question, and the answer is not at the moment. At the end of the talk, I'm gonna tell you about a couple of new venues that we're exploring, and I'll touch on that. Where are the artifacts stored if one doesn't have ResearchDrive access, such as non-faculty PA? So if you don't have ResearchDrive, you can always store your things directly on this server. This is the test server, right? So this test server has some storage associated with it, and I could save, let's say, so the original, I have an object called original penguins here. And if I want to save them, all I will do is, write CSV, penguins, and I'm gonna write it to my data folder right here. Yeah. That's how I will do it. And it will be stored locally on the CCI server that hosts Workbench.
And Alan asks if can you connect it to your Google Workspace or Box Quota, so if you can have your storage over there and then still be using it from this Workbench.
Excellent question, and I will cover that in the next few minutes.
Okay.
All right. Any other questions? Okay, we covered them all. So let's move along. And this part of the talk is intended to highlight how the Workbench can work with other aspects of the services we provide at RCI. So imagine that they are capturing and tagging penguin in the 3 islands, and they were doing that manually. But let's, in our fantasy world, we're collaborating with UW-Madison Starship Technologies. You have seen those little, the pizza delivering robots that are all over. And they created one machine that grabs the penguin, measures the penguin, and tags them, and does all the things. And it looks like this. As you can see, I draw that, not Allison, who is a great illustrator. So basically now in Janus Island, these machines are just roaming around and grabbing the penguin and tagging them and create a measure in them. And what happened with the data? Well, the data is being pushed somewhere. So let's check the code of how this penguin is generated. And so that is more penguins. So here is an Armor Down document that I created. It uses a few packages, and it reads from ResearchDrive those original polymer penguins. So let's do that. And so this is what this is intending to do is simulating what this penguin capturing device does. And so I have a build length, build depth, the flipper length, and the body mass, and I'm going to, to create a quick linear model using the original data set. And so I'm gonna run this. And then I'm gonna create new data. This is data that this machine is simulating based on this linear model that I created up here. And I'm gonna call that new data. Oh no. Everyone's up.
Cursive live demos. We've all been there.
Oh. I was cleaning this yesterday. There we go. So this is what a new penguin would look like, right? This was me. So I'm going to give the new penguin a simulator sex and the year in which it was captured and the hour and all of that. And I'm gonna call that thing a new penguin. Let me run this. So what all of this means is by now I have a new penguin that was captured in Torgerson Island, is Adderley, and it has those measurements. And here's where Cloud Tools can help you. Is aptly named Cloud Magic because I understand just like around 65% of how this magic works. But this section shows you how you can use Connect to run this script every minute, every 10 minutes, or every minute, and then push that to Google Sheet, which hopefully answers the previous question. So I have a couple of credentials stored there, and I'm gonna grab a token, and I'm gonna make sure that Google Drive and Google Sheets are using the same token, and I'm going to append this new penguin I just created up there to this sheet. So I'm gonna do that. Boom. So right now my Google Sheet has one more penguin that I just generated here. And in this make-believe world, this is simulating this machine that just captured the penguin and measured it. So what, remember Connect? That script is right here, more penguins. So ideally, I would like to simulate that this machine is doing that every so often. And there are tons of answers out there on how to schedule tasks. And you can imagine that any research team have good reasons to schedule tasks that they want to be run automatically. Well, Connect make this super easy. So this script that we just run by hand here is in Connect. I can come here and say schedule, and I'm going to schedule this to run every, say, 5 minutes, every 10 minutes. And I save this. And now this is going to every 10 minutes is going to run and generate a new penguin, and it's going to attach it to a Google Sheet. And so let's check that Google Sheet, see what it looks like. I left this thing running for a while now. It's called Penguin Capture, and it was running for a month. And so right now I have, so my machine has been capturing and tagging 67,535 penguins. And it does this every 10 minutes. It just got a new one. And so that's one other way in which Connect can help you. Let me go back here to, so you might have got, how are we doing in time? We had the last 10 minutes for questions.
If you want to do the last 10 minutes, you got 2 minutes to finish.
All right, so let's, last 5 minutes. So I have minutes to finish. So
yeah, some of that all day.
If you caught, I was using this word called data artifacts. And so the idea with data artifacts is that your research might be generating things that are different from, just papers. You can be generating, in this case, penguins. I'm generating, if you have smart instruments, you might be getting access to a stream of data that is being produced every so often. You may be generating plots or tables that are an indication and outcome of your research. And so I'm going to pretend that one of the things, that model that I created for the penguin is something that is valuable to us, and is the logic behind making this penguin. So remember I was assuming that all the penguins, because of climate change, were moving to an island, and now I have this bunch of penguins, and then my need is to identify them. So I can do that using, machine learning. And so what would that look like here on the data science platform? Well, I have this armor down document. I'm going to grab my Palmer penguins, my tidy models. I'm going to read it from ResearchDrive. You don't have to do anything, just read it. And I'm going to make a couple of things. I'm going to drop my NAs. I'm going to make sure that my species is a factor, and that gives me that. I do a little visualization. Yeah, I see the cluster nicely. The Adelaide penguins are here. The Gentoo penguins are here, and the chin stripes are here. So they cluster nicely. So I'm going to just work with my body measurements. I'm going to call that filter penguins. And I'm going to create a model using tidy models. Super easy. I'm going to use random forest. My engine is going to be Ranger, and my mode is going to be classification. And I'm going to fit species as a function of build length, build depth, flipper length, and body mass. In other words, all the body measurements that I've been using. And I'm going to assign that to model. And there's my model. Has all the specifications there. And I'm going to, again, I want to write this. I'm going to grab my simulated data, and I'm going to use my model to predict. So as you can see, you can easily read and write back from Google Drive. And this is just a quick, the species that were Adelaide, and I predicted as Adelaide are 30,000. I have some mistakes, so it's not a perfect model to be expected. The Gentoos are the ones that are better predictors. And then I'm going to explore my model. So it's taking a little bit too long. Let me just export the model now. Okay, so I export the model to connect. What that means is this. Now I have on connect that model as an API. Right. So I have this URL, and I can hit that URL with new data. So let's say I'm hitting this with those particular data. So I'm going to try it out. And if I execute this endpoint, it's telling me this Adelaide chin stripe and Gentoo is 96.55% sure that it's a Gentoo.
That's a little bit small for us to see, but I don't know if you can make it. Well, too big. But that, yeah. Ah, there.
So it's probably not an Adelaide. It's probably not a chin stripe. It's probably a Gentoo. So now that the model is on Connect, you can hit it with anything that is not R. So remember here, I'm going to, yeah, sure, save that. Let me just exit really quick. Let me create a new session. Let me make it a Jupyter Lab session. So I'm now working on Python, right? So my other half of the team that works in Python, you know, they can do this kind of things. They're importing this. They can also read and write to ResearchDrive, and they can do all those kind of things. So here's the important thing. So this URL that I have here is this URL that I have here. And I'm going to use that. I'm going to check the last penguin there. And I'm wondering, what kind of penguin is this? I'm gonna pretend I don't know the species. So I'm gonna just grab the physical measurements that I have here. I'm going to create headers for my, to hit the API. And then going to actually hit the API with that new data. So let's see what happens. I'm going to check the response, and there we go. Remember, it was again two. So from Python, I'm using the API that I created on R and I published to Connect to make it truly multilingual. And I'm up to 11:55. So I was going to show you what happened when you can grab those new data and then put it back into a Globus point and then share it back to Dr. Gorman, but we're going to skip that part. And we're going to use the last 5 minutes for questions.
I have a quick question, of sort of a summary question. So we're in Workbench in programming in a browser. Mm-hmm. And then at that point, we can access our ResearchDrive, or we can access some local to Workbench storage. Right. And then from ResearchDrive, we can point Globus at it and make that data. Or if we throw a model in there to deploy, we can access it from Globus for anyone to access it.
Yes.
Okay. Does Workbench work with GitLab, GitHub, one of the two?
Excellent question. So remember so let me just re-render this. And while this re-renders, look at this. Here I have
perfect.
My project is version control on GitLab. GitLab, if you are not familiar with it, is also a tool managed by the middleware team. And as a researcher on campus, you get access to it. So you have your GitLab account. And of course, if you don't like GitLab, you could use GitHub. It works basically the same. So you just go here, you commit, and just may during the talk. And normally, and I'll admit, normally I do a push. This doesn't let me push, so I tend to go here and force a
pushy,
and the push manually.
Oh,
but normally it's I don't know why is it not working here right now, but yeah,
because you're demoing live. That's why it's not working.
That's why.
Mary dropped the link into to more information about the Do It GitLab.
So yes, and here, just to go to that loop that Amanda was talking about, at the end, I was going to grab those new penguins and share them back with Dr. Gorman just by writing it to ResearchDrive. So there are a bunch of other questions.
Just more comments.
More comments. Future steps, and that lets me go back to the GPUs. We are working actively on an integration with CHTC. So the hope is that here, remember, here you create a new session, So let's say here and here soon, instead of local cluster, we're going to see a Kubernetes cluster and a Slurm cluster. So if you want to launch into CHTC, you will use a Kubernetes. And if you want to launch into the HPC, you will use the Slurm cluster. So this is in the works. Access the recordings, yes, the recordings will be made available later in a week from now, I believe. Any other question that I'm skipping? Feel free to unmute if you want.
I may have looked away for just a second, but when I say you can access ResearchDrive from that workbench, you can also access your Google workspace, like Google Sheets and stuff. You were writing to a Google Sheet, but can you read from one too? And that's two-way.
You can read it back and forth.
I just missed that.
Not because it's Workbench, but because there are packages that let you do so.
Oh.
I see a few more
All right,
questions.
fantastic. Yes, and we are at time. Thank you, everybody, for attending. Thank you, Erwin, very much for sharing information with us. Is it okay if folks reach out to you and if they have follow-up questions?
Yes, and my email wasn't the thing that I closed. My email is my last name, Laris, @wisc.edu. Thank
you very much. There's a break in the programming now from noon until 1. So come back and join us again for an ATP update at 1 if you wish. And enjoy the rest of the content. Thank you, Erwin. This recording will be available probably next week.
Yeah, thank you everyone for listening to me ramble about Penguin.
And congrats on your PhD.
Thank you so much.
Thanks, everybody.